Good morning. My name is Mackenzie Vedas, and for my lab experiment 9, equilibria buffers, I will be focusing on the Part B calculations. So the first part of Part B is to find the initial pH of the buffer. So in order to do this, you're going to find what the total solution is. So you would take the 10 milliliters of the 1 molar acetic acid solution plus the 10 milliliters of the 1 molar solution of sodium acetate, and when you combine that you get 20 milliliters, which is also 0.02 liters. So you would take your first 0.02 liters of total solution times the 1 mole of your acetic acid over 1 liter of solution to find 0.02 moles of your acetic acid. Now, a little bit further down, I have it marked that this is going to be our HA in our pH equation. Next, you would take the 0.02 liters of the total solution and multiply it by 1 mole of the sodium acetate solution over the 1 liter of solution, and that would equal 0.02 moles. So right off the bat, when we see that these two are identical, that your A and your HA are the same, it's going to be the log of 1, which is really just 0. So you know that your pH and pKa are equal, meaning that our pH is 4.76. So now that we know the pH, we can find the pH after 20 drops of HCl. Now, the reason I skipped ahead is because the calculation for 10 drops was already completed, so I just skipped to 20. So the setup for the drops is very similar, so I'm just going to go really in depth for this one and then kind of broad over the next two. So the first step you're going to do is you're going to take your 0.001 liters of HCl. Now the reason we know that it's that is because we had 1 milliliter, so we had to change it to liters. And we're going to multiply that by the 1 mole of hydrochloric acid over 1 liter of solution, and that will give us our moles of HCl. Now, when we are talking about the acetic acid and the sodium acetate, we will be adding the mole of HCl to give us a total mole of 0.021 moles, and we will be subtracting the 0.001 mole of HCl from the sodium acetate, and the reason we're doing that is because of how the pH will shift. So we are going to then divide what we got for these two answers by our total solution. So for this one, it's just going to be 1. And then when we get our mole solution for the sodium acetate divided by the whole, we get 0.9. So when we go to do our pH equals pKa plus the log of A over HA, we would plug in 0.9 for HA because that is our base, and we would put 1 for our HA because it is our acid, and then we would put 0.9 for our A because it is our base. And when we do those calculations, we get that for our pH. Now, over to the side for the addition of the base, it's the opposite. And I have a small note that you could do, because this is an inverse, you could also do the negative log and have your A over HA like we did here. But for this, we are going to do it the way that the lab showed, and we would take the 4.76 plus the log, and we would put 1 on top and then 0.9 on the bottom, and that would give us the pH for the others. Now for the 30 drops, it's much the same, except now our total solution has changed. So we have 1.5 milliliters, so that changes the liters. So instead of having, like in 20 drops, having just 0.021 as our total, now we have 0.0215. And then much of the calculations are the same, and here we just continued on doing that. And then for the 40, again, it's all the same, but now we're talking about 2 milliliters, so that changes our total, and then the calculations are much of the same. So one thing that we can note to kind of conclude is that as HCl was added, the buffer worked to keep the pH close to 4.76, and as NaOH was added, the buffer also worked to keep it close to 4.76. Thank you for watching and have a nice day.